Okay, today we're going to put it all together now for an Atwood machine. What's an Atwood machine, you ask? This is sort of an Atwood machine. An Atwood machine is just 2 blocks and a pulley, basically. Alright, so we're going to start with level 1, and then we're going to be ramping it up a few times to see some different situations. So here's the kind of thing you're going to see. So what we do is we have one mass on wheels. Let's pick some numbers for this one. Let's say that this one is 5 kilograms. And we're going to have this mass, we'll say this mass is 3 kilograms. And what we're going to figure out 2 things. We're going to figure out what is the acceleration, and another thing we're going to figure out is the force of tension. What we mean by force of tension is force of tension in the rope. Alright, let's give you an example here. So this M2 right here is going to be pulling downwards. So there's going to be a force of gravity. What's the force of gravity going to be? Let's figure it out. So F is equal to MA, in case you haven't heard yet. So if it's 3 kilograms, 3 times 9.8 is 29.4 newtons. So that is the force. Now this guy also has force of gravity on him, and it's going down. So this FG is going to equal whatever 5 times 9.5, I think it's 49, right? 49 newtons. But it has a normal force because it's on the table. So force normal is equal to 49. So there is no net force. Okay? Now, that takes care of the one on the left. Now, there's another force here. This is the force of tension. Now, here's why. Let me explain it to you. Let's pretend the rope was cut, and you just dropped it at M2. It would hit the ground faster than if the rope was still there. I think you'd all agree with that. That means that it has less acceleration with the rope. But the gravity doesn't change, so there has to be another force that's pulling up, and that's what this force of tension is. Because it is pulling, it is accelerating this M1. This is also experiencing a force of tension to the right. These forces of tension are going to be equal to each other, and they are going to be less than 29.4, because this is what's pulling down, and the force of tension is pulling up, but it's moving down. It's accelerating downward. So it's fighting a losing battle here. All right, whatever. So let's figure out what this force of tension is. It's easier than it sounds, because what we're going to talk about now is how to figure out the acceleration. We want to figure out acceleration first. There's a formula to calculate acceleration. It is F is equal to ma. Have you heard it before? So what is the net force on this whole situation? It is going to be 29.4 is the net force. That's everything that's doing something. What is the m going to equal? Well, we are accelerating 2 things. We're accelerating the 5 and the 3. So the mass is going to be 8. And then we're going to multiply by a, so that means that our acceleration is going to be 3.7. meters per second squared. So this is the acceleration of the system as a whole. Alright? So, as a whole, the system is accelerating at 3.7. You'll notice that 3.7 is less than 9.8. This one wants to accelerate at 9.8, but it can't. So, what we know, I'm going to draw just M2 here. So this is M2. There's a force pulling this one down at 29.4, and there's a force pulling it up at something, Ft. But I do know how much it's accelerating. It's accelerating by this much. Okay? So if I add all the forces together, so I know that F, I'm going to say net for this one because it's the first one, is going to equal the force of gravity plus the force of tension, right? Because if I add them together, I should get the net force. And the net force, remember, is the one that's with acceleration. Okay, so my force net is going to equal m times a, right? M times a. So my mass is 3, my acceleration is 3.7. That's going to equal Fg, which is 29.4, plus Ft. Now I just got to solve for Ft. So 3 times 3.7 is 11 point something, but small. And then, so I'm going to subtract 29.4, so I get negative 18.4 thereabouts. Alright, equals force of tension. Now, I know you're freaking out because it's negative, but here's what I made a boo-boo with. I mean, it doesn't matter too much, but this is actually a negative number here. Right? Because these are opposite directions of each other and they're vectors. So what we should be doing instead is adding. So we're going to take our 11 plus 29.4. So it's not going to be this one. It's going... Wait, hold on, sorry. Yeah, my bad. My bad. This is going down, but our net force is also going down, right? So we are going to add it, but it's negative, so we're going to get a positive 18.4. All right? That's going to be our force of tension in the string. Now, let's recap here because we want to make sure you're okay. Everything going down should be negative. Gravity is going down. It should be negative. This is going down. It should be negative. So when we put these together, this is going up. So it's going to be positive. So that's how we get 18.4. This also fulfills the requirements how it's less than 29.4. Okay? Alternatively, if you're not sure, you can always check by looking at the other one. Let's look at M1. M1 only has one force that's acting on it. So its force is going to equal m times a. Its mass was 5. Its acceleration was 3.7. And wouldn't you know it, 3.7 times 5 is equal to 18.5, which is the same as this one, give or take rounding. Ta-da! So the force of tension is the same for both sides of the rope. You just have to figure it out for one side, okay? It would have been easier to do it on the left, but that won't always be the case, for example, for this one. What we've got here is two masses, mass 1, mass 2. We'll say that mass 1 is equal to 4 kilograms. We'll say that mass 2 is equal to 6 kilograms. What we're going to do is we're going to drop him from rest. We want to know what's the acceleration, and we want to know what the tension is in the rope. If you're feeling confident, go ahead and pause it. I'll catch up to you there. Same general steps. So let's draw the forces to get us started here. So we're going to have 4 times 9.8, which is equal to 39.2. And this guy is going to have 6 times 9.8, which is 58.8. Nice. All right, this is going to have an FT, and this is going to have an FT. Don't worry about the pulley. Okay, so what we're going to have this time is a force of tension that's between them, because it's going to have the 58.8 going down, and the 39.9, it's going to be going up. All right. So let's figure out F is equal to MA, the net force. The net force is going to be 58.8 minus 39.2. So that is going to be how much it is going to be dropping divided by the mass. The total mass is 10 times A, right? Because this much total force is accelerating this much total mass. So put them together. So we're going to have 58.8 minus 39.2 is 19.6 is equal to 10A, so A is equal to 1.96 meters per second squared. Alright, it doesn't matter which block. Okay, just ignore that shutter. But, so now that we have the acceleration, we're going to pick either block. I'm going to pick the one on the right because YOLO. So this guy right here has a force going down at 58.8 and a force going up at something, Ft. So I know that F net is going to equal force of gravity plus force of tension. I also know that this one and this one are going to be negative because they're both pointed down. If you did the one on the left, the net force would be positive, which might have been easier. Oh well, that's what you get for YOLOing. So F is going to equal 6, because it's m times a, right? M times a is going to equal 6 times 1.96, and that's going to be a negative, and that's going to equal negative 58.8 plus Ft. And then we just got to solve that for Ft. So we're going to have 6 times 1.96 negative. And then plus 58.8 go 4704. Just 47 newtons. Hey, and this makes sense because it's less than this one. So that way this block will be accelerating downward, and it's more than this force. So this block will be accelerating upwards. So that is aligned. Let's look at the next level. So here we've got an Atwood machine on an inclined plane with M1 is 14, M2 is 7, and alpha is 39 degrees, because of course it is. And don't worry about that, because the rest of the problem got trimmed away. So what we're going to figure out is the same thing. What's the acceleration and what's the force of tension? Hopefully you're noticing some patterns here. See if you can pause the video and set up that triangle like we did yesterday, those forces. Hopefully you did it right. So I've got a force here. I'm going to start with the easy one. I know. 7 times 9.8 is 68.6. And there's going to be a force of tension there. The force of tension is going to be right here. And then we're going to have gravity going down there at 14 times 9.8. 137.2. 137.2. We're going to have our triangle like there, beautifully drawn to scale. The 39 is in the right place even. So 137.2 times sine of 39. This guy is going to be 86.3. Alright, now there is going to be a normal force here, right? Force normal. We can figure it out. I mean, sure, what the heck. 137.2 cosine of 39. It's going to be 106.6, 106.6, and that's going to equal this. Then we're not going to do anything with force normal yet, not until next week. Ooh, foreshadowing. But this is all we need to do. So this is the first step. You should set up all your forces. Okay, now the ones we care about are the 86 and the 68. So which way is it going to go? It's actually going to go that way. So let's figure out what the acceleration is. So F is equal to ma. We have two counteracting forces. So we're going to have 68.6 minus, 86.3 minus that is equal to, total mass is 21 times A. So we're going to have 86.3 minus 68.6, enter, divide by 21. So acceleration is going to equal 0.843, whatever, meters per second squared. Okay, do you think you can figure out what the force of tension is? If you vote now, you might be able to pick which block I use. Well, the votes are tallied and it's a tie. So I'm going to pick the one on the right because it's not at an angle, because who likes angles anyways? Oh, this one's going up. It should be nicer. So we're going to have force of tension, and we're going to have force of gravity. So I know that my net force, which is caused by acceleration, is going to be 7 times 0.843, and that's going up this time, so I'm going to leave it as a positive number, is equal to force of tension, because that's going up, so it's positive, minus the force of gravity, which is 68.6. So now I just have to do that times 7 plus 68.6. Enter 74.5 newtons. Ta-da! Now, I know what you're saying. Mr. Keeney, that was awful, doing it on an angle. Well, let's look at the next problem. Whoa! 2 blocks connected by a cord passing over a small frictionless pulley rest on a frictionless plane, as in the figure. Whatever. Which way will the system move if they're released from rest? So M1 is a hundo. M2 is 50. Okay, what's the acceleration of the blocks? What's the tension of the cord? Same kind of thing. They love this kind of question. This is why we're doing it a bunch. And it practices everything from the week. So what we're going to look at here is, see if you can set up all your forces. Go. This one is going to be 9.8 times 100, so 980. This one is going to be half of that, so that's going to be 490. But of course, we have to break these apart into their components because no one likes a diagonal force. So this is 30 and this is 53.1, which is oddly specific. So if this is 30 and that's 980, this is going to be 490. And the other one, which technically doesn't matter, but 980 times cosine of 30, well, I should say it doesn't matter for this one, 848.7. So 848.7, we should also be drawing the normal force, right? Which is also 848.7, right? The reason why, because it's not accelerating in or out of the triangle like that. And there's also a force tension, which we're going to be finding out later on. Okie dokes. So now we're going to have 490 times sine of 53.1, which is 391.8, 391.8. And then we're going to have the same shebang, except with a cosine. 294.2. 294.2, and that's going to be the same thing as up there. Okie dokes. These are 90s. Alright, so now which way is it going? Well, it's going to be going to the left, to the left, to the left, to the left, because this force is bigger than that force. So what we're going to do now is to find the acceleration. So F is equal to ma. Have you heard of this formula before? So F is going to equal 490 minus 391.8. And that's going to equal 150 times A. Let's type that in. 490 minus 391.8. Enter, divide by 150. So acceleration is going to equal 0.65. Ta-da! Alrighty, do you want the left or the right? Vote now. I'm going to go with the left. So here's my block. Gravity. That, normal force. Force of tension. Alright. So my net force, my F net, I'm just going to draw it so that way I don't lose track of it. I'm going to put it in double lines so that way I really don't lose track of it. So there's 2 forces here that matter. So there's the FG parallel and the force of tension, right? Those are the ones that are combining to get the force net. So my force net is going to equal my FG parallel. I'm going to say minus force tension. Is that okay? I'm just going to call this direction the positive direction, that direction the negative direction. Doesn't matter? Not at all. So my force net is going to be a hundo times its acceleration, which is 0.65. I wonder what that is. And that's going to equal my force of gravity parallel, which is 490, minus Ft. So I'm going to boom, boom, slide these around. So 490 minus 65. So that means my force of tension is going to equal 425 newtons. Ta-da! And that makes sense. That is definitely between the two. Woohoo! Okay, I think there's one more thing that we're going to look at here, just to combine it with some old stuff. Alright, easier situation, but we want to work it backwards. This time I have this Atwood machine that was definitely not squished, and it is definitely a circular pulley. Now, it's going to have an 8 kilogram, which drops 2 meters in 3 seconds, and an unknown on the other side. What is the unknown mass 1? Ooh, if you think you can figure it out, pause the video and go for it. So what you're going to do then is you have to figure out what acceleration is the old-fashioned way. So what we do know is that d is equal to d0 plus v0t plus 1/2 at squared. So d is 2 is equal to 0 plus 1/2 a times t, which is 3 squared. Okay, so times it by 2, divide it by 9, so we're going to have 4/9, which is equal to 0.444444 meters per second squared is equal to the acceleration. Okie dokie. So let's figure out our forces then. So we're going to have 8 times 9.8, which is equal to 78.4. And then this guy, which is our force of tension, and the same thing for here. Force tension, and this one is going to equal our M1 times G, which we don't know what M1 is yet. So let's figure out what the force of tension is. You're basically doing the same thing in reverse a little bit. So for this guy, the 8 block is accelerating downwards. I like to use a double arrow for accelerations if I need to. So because I don't have different colors on this beautiful software that's a few years old. So force net, which is going to be negative, is going to equal negative force of gravity plus force of tension. My negative net force is going to be 8 times 0.44, which is going to be negative, is equal to negative 78.4 plus Ft. Okie dokes. So negative 8 times 0.44 is equal to that, plus 78.4 is equal to, so force of tension is equal to 74.88.9 whatever newtons. So now I know what this is. This is going to be 74.9, and I just have to figure out what this is. So same kind of thing as what we did here. This one is accelerating upwards. So my F is going to equal, this one's going to be a positive. So that means my force of tension is going to be a positive, and my gravity is going to be a negative. Now, you could reverse all these, it doesn't matter. Okay, so we're going to have F, which is m1 times its acceleration, which is 0.44, because it's the same as the other guy, is equal to the force of tension, which is 74.9, minus force of gravity, which is going to be m1 times 9.8. Alright, so now we have some like terms here. We have to combine those, bring them to the other side. So 0.44 plus 9.8, which is 10.24. So we're going to have 10.24 m1 is equal to 74.9. So then we have 74.9 divided by 10.24, and we're going to have m1 is equal to 7.31 kilograms. Now, let's think about it. Does that answer make sense? Yes, it does make sense. It must be lighter than the 8 kilogram one. Now, it is not lighter by a lot because it took so long for this to drop. So it's not going to be very much different, but it is going to have to be lighter. Ta-da! Hey, so that is how you can solve anything you wanted with Atwood Machines. I know you got your money's worth, but we also practiced a lot of stuff from earlier in the week, and hopefully all these sample problems can make your life just a little bit easier. Or not. We'll see you next week on the next episode of AP Physics Online.